Good day, class.
Good day, ma.
Okay. I am Chiwendu Chiazo. I'm your grade 9 physics teacher. Today, the objective of today's class is to identify and describe with the use of diagrams. With the use of what?
Diagrams.
The behavior of wave in water and in air. There's a way that wave behaves. So today we want to identify these behavior. We should be able to define them. Then we should be able to call their names by seeing their diagrams, or probably make a diagram that represents some of these behaviors. Is that possible? Is that possible?
Yes, ma.
Is that very possible? Okay. So, what is this?
It's a ball.
It's a ball. Okay. If I throw this ball in front of me, hard enough to hit the wall, what do you think will happen?
It will bounce back.
Okay, so let me try one in front of me. So, if I hit it like this, it comes back the same direction. Okay. There's another thing that behaves that same way. If I point a torchlight on a mirror, what do you think happens?
It bounces back.
It shines back to me towards the same direction. So we want to also see that wave behaves the same way. There's a bounce back in wave, in the behavior of wave. So we are going to discover what it is called. Okay?
Yes.
Are we together?
Yes.
But before I continue, I want us to recap, to do a little recap. In the last class, can you remember what we learned in the last class? Okay, we learned the definition of wave. Oma, can you give us the definition of wave? Can you remember?
Wave is a disturbance that travels through a medium transporting energy from one location to another without transporting matter.
Beautiful, beautiful. So wave is a disturbance. And we are also able to categorize wave into, Daniel, into transverse
and
longitudinal. Beautiful. Transverse and longitudinal. And we are also able, can you remember that we are able to bring out some properties of wave? David, can you help us with that? Frequency. Wave has frequency. Amplitude. Period. Wavelength. And velocity. Beautiful. Great. Thumbs up. All right. This is wonderful. That means you remember what we've learned in the last class. Okay. So now we are going to watch a very short video, and I will need you to pay attention, because the video is going to be describing the different behavior of wave. I will have to ask you questions after watching this video. I would need you to get a name for the bounce back. Can we achieve that?
Mm-hmm.
Are we ready to watch the video?
Yes, we are.
All right.
Look at how light and sound waves behave. Before we start, you should know that waves can be transverse or longitudinal. To learn more about the properties of waves, watch this video first. Transmission, reflection, refraction, diffraction, absorption, and scattering are all typical wave behaviors. Reflection is when waves bounce off an object. Sound waves are reflected by hard, flat surfaces, and is why we get echoes. You hear a delay between the original sound and the echo, because the echoed sound waves have to travel twice as far to reach your ears. Smooth surfaces, like glass or polished metal, reflect light in a regular way, so a reflection can be seen, like a mirror, or seeing your face in a calm pond. Transmission is when waves keep traveling in the same direction through an object, like light through a window. Absorption and reflection often go hand in hand for light waves. White light contains each wavelength, so all the colors of visible light. The color of an object depends on which wavelengths of light it absorbs and which it reflects. White objects reflect all the light that hits them and absorbs none. Black objects reflect none and instead absorb all the light that hits them. A red object absorbs all the wavelengths except the red, which is reflected. And a green object absorbs all the wavelengths except the green, which is reflected. Waves pass across a boundary between two substances. Like air and glass, they change speed. This is because the substances have different densities. The change in speed causes the waves to change direction, which is known as refraction. Because of refraction, things in water look closer than they really are. Water appears shallower than it really is. And a straw in a glass of water looks like it bends at the surface. Because the refracted light wavelengths make you think the straw is in a different place to where it actually is. When waves meet a gap in a barrier, they pass through the gap. They then spread back out after they pass through the gap. This is diffraction. The way the waves respread depends upon how big the gap is compared to the incoming wavelengths. We have diffraction to thank for loudspeakers. Sometimes waves depart from the expected path and spread out in multiple directions. This is known as scattering. We have scattering to thank for making the sky appear to be blue. The white light coming from the sun hits the molecules in our atmosphere, which causes the shorter blue wavelengths to scatter out in all directions. So waves behave in a variety of ways, depending upon what material they hit.
Okay, did you get something from the video?
Yes, we did.
We did. Beautiful, beautiful. Something very important. I watch all of you and you were watching the video with great interest, and that was fantastic. That means you're paying attention. Now, what behavior of wave is similar to the bounce back of this ball on the ground? What behavior of wave is similar to this character? Reflection. Beautiful. Nice. Reflection. So that means the way the light bounces back from the mirror and the way the ball bounces back from a hard surface, the wave also has a form of bounce back that is referred to as reflection. I have a chart here, and I believe you have the chart in front of you. Do you have this chart in front of you?
Yes, ma'am.
Please let us study the chart. Look at it very well. Look at the chart in front of you very well. Can you see the incident ray falling on this surface? Just like a ball falling on a hard surface, right?
Yes.
What happened? And you see it bouncing back. Okay. Can you see this wave?
Yes, ma'am. Yes, ma'am.
Moving towards a reflector and it going bouncing back. Okay.
Yes.
So what diagram? There's a definition here. Let me read out it. Dash is when wave bounce off an object. Dash represents when wave bounce off an object. What should we feel here? Reflection. Beautiful. So now when you see this diagram, you can see that there's a diagram. This diagram represents reflection. So you're going to study this diagram on your table. This chart on your table you're going to study. Then we have some other charts. Do you have charts too on your table?
Yes, we do.
Okay, so let's look at it keenly. Look at it. Study your chart too. Can you see what's going on there?
Yes, ma'am.
Okay. See the waterfront coming from Earth. See the source, the arrow. Look at the ones on your table. Yes, pay attention. Okay. Yes. What can you see there? It said dash is noticed when sound and light wave pass across a boundary between two substances like air and glass. What do we notice? You know, you watched a video that gave us great explanation on what is going on when a wave moves from one substance, from air to water. Okay? You see some changes, right?
Yes.
Both in the speed and the way the wave is dispersed. Okay? So what do you think this diagram represents? Have we studied it?
Yes, ma'am.
Okay, what? Yes. Oh man.
It represents refraction.
Refraction. You see? The incident wave is refracted. It does not bounce back, but it passes through the medium, but changes the wavelength, changes the speed. Can you see that?
Yes.
You see the spacing here, and you see a different spacing here. Okay? Then we have chart 3 and the other charts on your table. I want you to work in your groups now. Study these charts and put a name. You have a definition on every chart, but without a particular name. Do you understand what is required of you?
Yes, ma'am.
I want you to work in your groups of 4s now. Yes? Group A, Group B, yes, Group B, Group C. I want you to work in your groups of 4s. What are you supposed to do? Study the charts and give them a name. Can we do that?
Yes, ma'am.
Remember what you saw in the video? Then compare it with the diagrams in front of you and the definitions in front of you. Then give them a name. I'll be moving from one group to the other to make sure that you are working. After that, I will give each of you an individual work to do. Can we do this?
Yes,
Okay. Yes. Group 1, group A, Group B, Group C. Beautiful. Let's start work. In the next, I will stop the group work in the next 15 minutes. Is that okay?
Yes, ma'am.
Okay. So let's start work.